All right, let's start off. This is video number 3. Um, let's go further into bonding. And so far we've considered single bonds. And let's try to tackle multiple bonds like double bonds and triple bonds and how they fall into the picture of bonding itself. Okay. So just a quick recap as to what we did previously. We looked at formal charge in the previous video, what formal charge is, and then we finished off by how water can split into either hydroxide, which is OH minus, or it can split into hydroxy radical, right? OH dot. And then we found out what the formal charge is. If it is hydroxy, it's a -1, right? And so we calculated formal charge and came up with -1. And if it's a hydroxy radical, we calculated the formal charge and we found out that it is a 0. So that's an important concept to remember, what the formal charge is, especially when we are talking about carbanions and carbocations, which we will come to very shortly. So before going over there, there's multiple bonds, right? We thought about oxygen, right? 1, 2, 3, 4, 5, 6. We said that, well, it could form one hydrogen here, form 8, right? This is what we talked about previously. You can get an octet this way, 8 electrons. So that's water, right? Perfect. What about if it wants to bond with itself? What about oxygen and oxygen? Remember, we know it's O2, right? So how does it bond? So if these two bond, it'll be 1, 2, 3, 4, 5, 6, 7, right? Something is missing here. So, it doesn't work, right? So a single situation like this, where a shared pair is between two atoms, is not enough to give it an octet, because the one over here, the electron on the other side, if you can call it that, remains unaccounted for. So what you can do is, at least in Lewis structure, this is called the Lewis dot structures, right? Lewis dot structures. So what you do is you put oxygen like this: 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, and so you share. These are shared. These 4 are shared between the atoms. That means, since 2 electrons is a single bond, there are 4 electrons. So 1, 2, 3, 4. Then, since there are 4 electrons, that is oxygen. Okay, so there's a double bond. So there are 4 electrons between the 2 oxygen atoms. That's a double bond. Okay. Similarly, moving forward, nitrogen is what? What is the how many valence in nitrogen? Anybody? Or 5, right? So it's 1. Well, we call it 1, 2, 3, 4, 5, right? You can write the other 1, 3, 4, 5. Forget about this one. Now these 6 are shared, so that it becomes an octet, right? Fully. So that would be N. That's nitrogen molecule, right? So this is a triple bond. So something to keep in mind is that there doesn't have to be just a single bond between between atoms. There can be multiple bonds. Multiple bonds come because of sharing multiple pairs of electrons between bonds. And sometimes it's depicted as 2 lines, 3 lines, etc. between atoms. It's 2 lines, double bond, 3 lines, double bond. So this is a very basic about how molecules come together, etc. Right? We know that in chlorine, there's only one, right? Shared. It's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. You don't need double bonds here. If you just share these, that's enough. That's an octet, right? So that'll be Cl, Cl, 1, 2, 3, 4, 5, 6. That's Cl2. Just because it's a Cl2 doesn't mean there's a double bond. A molecule, single bond. Okay, so keep that in mind. Just because you see a 2 doesn't mean it's a double bond between them. Only for oxygen, nitrogen, etc. that cannot satisfy an octet without multiply bonding with other electrons. Okay, I hope that part is clear. Great. Important deviation is the chemistry of bonding in carbon, right? So now that it's coming to our class, because our class is mainly carbon-based, so what is the bonding in carbon, right? Important to know. So what is carbon? What is the electronic configuration of carbon? Let me get the periodic table again. For those of you so where is carbon? Hydrogen, helium, lithium, beryllium, boron, and carbon, right? So carbon has what? 6, atomic number 6. So 6 electrons. 2 is out, right? 1s2, 2s2. So it has 4 valence electrons, correct? So carbon has 4 valence electrons. So it can satisfy 4 bonds, right? In order to, so if you have 4 other things, you can make it 8, right? So we'll leave it at that, and so I don't know if I have time to go through this. Let's look at it more. Okay, since we have a little bit of time, I can just go to a point and stop. Okay,